All right, so like I said, we are going to go into properties. So the first one we're going to discuss is direct substitution, okay? So direct substitution. And that basically states that if you have the limit as x approaches c of f of x, then your answer will be f of c. In other words, just plug in the value into the function, okay? That's all you're going to do. You're going to plug the value into the function and get your answer, and you're done. No need to draw it. No need to create a chart, at least for the most part. It's just plugging it in, okay? Now, you got to make sure that the function you're plugging it into is a well-behaved function, meaning it's continuous, okay? So I'm just going to put a little mark here. F of x should be well-behaved, as they call it. Okay. I guess you could say continuous. All right. So as long as f of x is continuous, then you should be able to plug it in any number you want and get an answer. If the function is not well behaved, so if it does have like some areas where like the graph has gaps in it, well then maybe you won't know the actual answer for specific places. So we need it to be continuous. Now, like I said, this section today is mostly just properties, okay? So that's what we're going to concentrate on, is just going over properties. You will not have new homework today, okay? I guess I call it properties of limits to be the more exact. So hopefully you guys have been working on yesterday's homework. I know it's pretty long. Just kind of take your time with it. You know, if you have questions on it, we can work on that stuff together, okay? So first off, given that we have B and C as parts of the real numbers. You guys remember that notation from trig? Okay. If not, I'll kind of make a little legend over here. This means element of. This is real numbers. So B comma C, element of the real numbers, meaning given that B and C are real numbers. Okay. So given that B and C are real numbers, and that n is a positive integer, okay? So this is an integer, and a power of plus means positive whenever you put it next to a class of numbers. So you could use a plus or minus, meaning positive integers, negative integers, right? So it would be z plus or z minus. So given that B and C are just real numbers, and that n is going to be a positive integer. Okay? So here's what we get. Number 1. The limit as x approaches c of b is just b. In other words, the limit of a constant is a constant. So if you're taking the limit as x goes to 7 of 10, then it's just 10. There's nowhere to plug in the number, right? There's no x values, nothing like that to plug in a number. So you're just going to use the constant itself. Okay, so the limit of a constant is a constant if you want to kind of write it out in words. But the limit of a constant is a constant. Number 2. So number 2 is the limit as x goes to c of x. So in other words, now you can plug it in. Well, that's equal to c, right? That's direct substitution. Number 3, the limit as x goes to c of x to the n is c to the n. So they're basically saying, look, it works with powers as well. Just plug in your information into the actual function and you'll get your answer. Okay, so they're just trying to tell you that, like, it's going to work that way as well. Okay, so really easy examples just to kind of show you this. We're going to evaluate. So let's find, I'm going to let you guys do these, okay? I'll give you a couple seconds. Here's another one. And one more. So go ahead and do those. And then we'll continue with more properties. So can anybody give me a part A? 4, right? Because that's just a limit of a constant is a constant, right? So there you go. That's just going to be 4. What about part B? All right, -8. And part C, that would be 8, because that's going to be 2 to the third, right? I guess I could kind of erase this and write the following. There'd be 2 to the third, which would equal to, in our case, an 8. All right, so, I mean, not hard. Just kind of know your properties, you'll be fine. All right, let me show you some other properties here. So, more properties of limits. Earlier today, during my Calculus BC class, the pen actually stopped working like it did a couple times during last year. So I did have to restart. So I hope it doesn't do it this time, but we'll see. Now still, given the same information as before, so given that B and C are elements of the real numbers and that n is an element of the positive integers. Okay, so given that B and C are real numbers and that n is an element of the real integers, we're going to let the limit as x goes to c of f of x equal to L and the limit as x goes to c of g of x, we want it to equal to k. So we're going to let that be true. And right now we're going to talk about like the scalar multiple property, the sum and difference property, stuff like that. So first thing, this is called the scalar multiple property. Scalar multiple. Now scalar is another word for the word constant. So constant multiple. In other words, you're multiplying by a constant number. The reason why we call it a scalar is mostly so that we don't confuse it with physics and thinking of the word constant meaning the gravitational constant, right? So we're going to use the word scalar, okay? So scalar multiple basically says this. The limit as x goes to c of b times f of x is equal to b times L, so BL. Okay, so notice they're just basically saying you get your limit of f of x, which is L, and then just multiply it times b. Okay, that's your scalar multiple. Sum and difference, that's the next one. Sum and difference. So the limit as x goes to c of f of x plus or minus g of x is equal to, well, the limit of f of x is L, and the limit of g of x is k. So it's just L plus or minus k. So they're basically saying, if you're trying to take the limit of two functions, then if you know the answers for both of the functions, just plug them in. So that's the sum and difference. We have a product and a quotient as well, so let's do the product one. So the product says that the limit as x goes to c of f of x, f of x times g of x is L times k. We have a quotient. Now this one does have a bit of a restriction, okay? So the quotient rule says limit as x goes to c of f of x divided by g of x. Okay? So if you're dividing, that's going to equal to L over k, given that our k value is not a 0. Okay, as long as the k value is not 0. So in other words, the limit as x approaches c of g of x cannot equal 0. And then they do have the power rule, so last one here. So limit as x approaches c of f of x to the n will be L to the n. They're basically just saying, figure out the limits first and then apply them to these properties. Okay, once you know your limit values, then you can apply them and you should be good. Just trying to see if there's anything that I really need to go over with you guys. It's like super important, but all right, so let's try doing this. We're gonna kind of go over a couple properties that aren't necessary. Let's do an example number 2. So I want to show you what it's supposed to look like when you do this using all the properties. But then a lot of people say, well, what if I don't want to do all that? What if I just want to do it in my head? I would actually prefer you do that. But let me show you what it's supposed to look like when you break it down. Okay, so find the limit as x goes to 2 of 4x squared minus 2x plus 1. So when you do a problem like this, you are supposed to break it down, right? But there's shortcuts to it, which you eventually get used to doing. But this is what I would do if I was going to follow all the rules. I would first do this. The limit as x goes to 2 of 4x squared minus the limit as x goes to 2 of 2x plus the limit as x goes to 2 of 1. Sorry? Oh, I put c by accident. Yes, it should be a 2. I think I may have said 2, but I didn't write it down. But there you go. So that's the sum and difference rule. Okay, the one that says, look, instead of just doing all of it, why don't you just do a piece at a time? Okay? So that's that. Now, notice how the 4x squared and the 2x have a constant in the front, or a scalar. That means I'm supposed to break it up like this. 4 times the limit as x approaches 2 of x squared minus 2 times the limit as x approaches 2 of x plus, what's the answer for the last part? That's just the 1, right? So notice I separated my scalar, my number, right? I put it to the side. Now, according to the power rule definition, number 5 that you can actually see up there, I can just plug in my 2 value into the x and do the work. So this will be 4, and this will be 2 squared minus 2 times 2, that's direct substitution, plus 1. So 2 squared is 4. 4 times 4 is 16, minus 4 plus 1. So this comes out to 13. That's just a lot of work. I would rather just say, oh, I just got to plug in a 2. Okay, I'll do it right away. Right? I would go from this step to that step immediately. Just plug it all in. Okay, why am I going to break everything up? The reason why I broke everything up is just to show you the use of all those properties we just talked about. I mean, we didn't use the quotient rule, but we did use like the product rule, we used the scalar rule, we used the power rule, sum and difference rule. We used 4 rules to do this. Actually, we even the direct substitution, that's another rule, right? So we use 5 rules to do this problem step by step. Or you can just skip it all and just say, I'm just going to plug it in, right? So I would prefer you just plug it in, like follow the yellow arrow, right? Do that instead. Just plug it straight in. Don't worry about going through all the process of it. Just know that that is there. That's the hidden math that you're not going to do, but it is there. It allows you to do the work. Okay? Now, there you can do the same thing with square roots as well. Okay, if you happen to have like a square root in a function, you can still plug in. So like something like this. So square roots, right now I'll move this up. Or you know what? Square roots, I'm going to put right here, or nth roots. In other words, any root. If you take limits of these nth roots, okay, for these problems, actually let me just call that x. That might be easier. It's going to work just the same like direct substitution. Okay, so if you see a radical, no big difference, same idea. It does not require you to do anything majorly different. And then they also have the same thing for composition of functions, but we're not going to worry about that because that's just kind of repetitive. Okay, and the same applies to trig. If they ask you to find the limit as x approaches c of sine of x, then you just plug it in. Okay, just plug in the stuff. It doesn't matter that it's trigonometry. For example, if I give you, I think this is 3, right? Or was that 3? Yeah. So if I were to tell you like to evaluate the limit as x approaches pi over 2 of sine of x. Okay, it works just the same. Sine of x is a function, so you're just going to plug it into your function. So this becomes sine of pi over 2, which is, what is it? 1, yeah, just 1. So notice it's not that it got harder, it's trig, sure, but you just plugged it in no matter what, okay? So don't worry about the fact that it looks different. It could be a sine, cosine, tangent, cotangent, cosecant. Who cares? You can always just use direct substitution. Okay? You can always use direct substitution. No big deal. Now I think, yeah, I'm going to give you one more example to do, and then we're going to stop. Tomorrow we will, or not tomorrow, but Monday, we'll go over techniques. Okay? Some other techniques for this stuff. But let me give you this example here. And I'll give you guys some time to try it out. So we're just going to evaluate. Number 1 here, limit as x goes to 0 of secant of 2x. Let's do the limit as x goes to 1 of sine of pi over 4x. And then here's the third one. The limit as x goes to 3 of radical x minus 2 over x plus 1. So I'll give you a little bit of time to do that. I'm going to pause the video recording, that way it's not just sitting there for like 2 minutes. All right, so let's go ahead and look at this, guys. So for the first one, you're going to do direct substitution, right? So you get secant of 2 times 0, which is just secant of 0, which is 1 over cosine of 0, right? If that might make it easier for you. What's cosine of 0? 1. So this is 1 over 1, right? So there you go. For the next one, use direct substitution as well. So you get sine of pi over 4 times 1, which is just sine of pi over 4. That would be what?
Rad 2 over 2.
All right, rad 2 over 2. Or 0.707 something. I don't know what else it is. And the last one is just direct substitution. We plug it in. We get radical 3 minus 2 over 3 plus 1. So that's radical 1 over 4. That comes out to 1/4. So you're done. Okay, like I said, tomorrow, or not tomorrow, Monday, we'll go over the rest of this lesson, but there will be no homework for this lesson today, okay?